Folks, in this video here, we're going to talk about one of the most important formula that we can use in factorization. Again, factorization is when you look at a quadratic function or a structure of a quadratic function, and you think, can I break it down into different pieces that can multiply together? For example, you've played Lego, probably. In Lego piece, these are the Lego pieces, right? That's how it look like when you finishing assembly. But are you able to deassemble it, break it apart? And how do we break it apart? That's the formula that we can use. There are different kind of formula, but today we're only talking about difference of square. The name difference of square, right? We call it dose, right? Difference of square. It's really, what does difference mean? It means something subtract another. That's how you find a difference. Of square. Well, you probably know what of is, right? What's a square? Okay, something, is it a square like that? Is it a square like that? No, it's the mathematical notion of square. That, let's say, if you have 7 square minus 5 square, this is actually a very, very easy demonstration of difference of square. Why? This is square. We have two numbers subtracting each other. We're trying to find a difference, right? So all of these formulas or all of these equations, we're actually using the same notion of difference square. It's just that you have to have a detective eye to see, okay, in this question here, as long as I see the subtraction happening here, will I be able to figure out whether this number can be something square or this number can be another thing square? And that's what you're trying to find out, is that you have the Lego piece and you want to break it apart based on the rule that if I can see if it's two numbers subtracting each other, I can actually break it down into pieces. For example, let's say question number 7, x squared y squared minus 16. Okay, I know my formula looks like this. A squared minus b squared is equal to a plus b times a minus b, right? That number square minus this number square is equal to this number itself plus that number and this number itself subtracting that number, okay? So in this case, x squared y squared, let me think. I can actually make this. If it's x, y, and then I power it, will that be x squared, y squared? Oh yeah, it is. So basically, this is just xy squared. Okay, so if that's the case, what about 16? Oh, 16 is actually 4 to the power of 2, right? I'm going to put a mirror image over here. So xy to the power of 2 is actually equal to x squared y squared. And 4 to the power of 2 is equal to 16. So in this case, this, that, right? This number plus that number multiply by this number, subtract that number. So that's my factorization, and that's it. That's my answer. We don't have to solve for x, we don't have to solve for y, we're just changing the shape of it. We're acting as a plastic surgeon. We're trying to change the shape of x squared y squared minus 16 into xy plus 4, xy minus 4. These two are exactly the same. It's just their form looks different. Sometimes you might wear sunglasses, sometimes you might just wear t-shirts. You're still you, right? Nothing changes. And that's the whole notion of it. Let's try a couple more questions here. So with that, let's try question number 16. All right. All right, user detective I, can you tell me if this is something square and this also is something square? So I started with notifying the answer here, 25, x squared, y squared. That looks like 5 square, x square, y square. So basically, this one is just 5xy to the power of 2, or square, minus, oh, this is 7 square, a square, and b square. So this is basically 7ab to the power of 2. Okay? I actually see that this is called difference of square, right? What's my rule again? What's my formula again? This number, which is 5xy, plus that number, which is 7ab, multiplied by this number, which is again 5xy, plus minus, oh, I almost made a mistake, 7ab. Is this the answer? 100%. This is all it wants you to do. It's just to see that if you have the detective eye to figure it out, you can see the squares. So let's move on. Let's say, okay, so this one, a little bit more difficult is that we're introducing the four squares here, right? We're trying to see that if we can find out we have the squares as well inside the numbers. Let's just have a random one over here. This one looks a little bit more interesting. Okay, so first of all, again, we have to have our detective eye, right? 16x to the power of 6. Ooh, the 6 is interesting. So what? I know 16. I know 16. 16 is just 4 to the power of 2. What about x to the power of 6? Oh, x to the power of 6 is actually x to the power of 3 to the power of 2. Am I right? I think I'm right, right? So to the power of 2. And what about 25y to the power of 4? 25 is 5 to the power of 2. Y to the power of 4 is y to the power of 2 to the power of 2. Okay, so this, although it looks a little bit more complicated, is really 4x to the power of 3 to the power of 2, right? So this number is 4x to the power of 3 minus 5y squared to the power of 2. All right, so that's that number. All I need to do now is this number, 4x to the power of 3, plus that number, 5y to the power of 2. And then this number, 4x to the power of 3, minus that number, 5y to the power of 2. Notice that really it's very simple that we just have to use the formula we learned, no matter what kind of numbers that we're dealing with. Guess what? The whole idea is the same. Okay, so hopefully this helps. All right, let's move on. Okay, so this is something different. We're taking the number out first, and then we're using the difference of square. The idea, again, is very simple. Why? Let's look at this number. We have 3ax y squared, 27ax. First of all, we have to find out, all right, there's nothing here I can actually make a complete square here because 3 is nothing to square. But a is also nothing to square. X also is nothing to square. What do? Okay, I learned before I can take out things first that both terms have in common. When I say terms is 3ax y to the power of 2 and 27ax. What do they have in common? I know they have 3 in common for sure. They have a in common for sure. They also have x in common. So when I'm done that, what do I have left? If I use 3axy to the power of 2, which is the original number here, divided by 3ax, I will only have y squared. Oh, did you see I have a square here? I'm having a good feeling here. Minus, what's 27ax divided by 3ax? Oh, it's 9. But what's 9 again? Hold on. Oh, 9 is just 3 to the power of 2. So it's basically inside a bracket, I have y to the power of 2 minus 3 to the power of 2. So again, the smart you, can you do a factorization for this again? So pause the video for a little bit and we're going to come back to it. All right, so it's just 3ax, this number, plus that number, this number, minus that number, right? That's my final answer. Again, you're not solving for anything. You're just breaking this apart into 3 parts, multiplying each other. Notice that 3ax is multiplied by the y plus 3 multiplied by the y minus 3. And that's really the idea for factorization because when you get the factorization answer, it's always terms multiply each other with bracket or without bracket. They multiply each other, every single one of them. Okay, so let's move on. So these ones looks pretty similar. Ooh, I see a very interesting question here. Let's see question number 16 here. X, Y, Z. X, Y, Z. At least I have what? X, Y, Z in common. And let's find out if we have something left. If I use X3, Y3, Z divided by X, Y, Z, I will have X squared, Y squared left. Look at that. It's already square, right? I have a good feeling about this now. And then if I divide X, Y, Z to the power of 3 with X, Y, Z, I have Z squared left. So again, xy squared minus z squared is how it look like. X, Y, Z, nothing changed with that. This number, which in this case xy, plus that number, in that case z, this number xy minus that number. All right, so again, three terms, xyz times xy plus z times xy minus z. Okay. All right, so this is something I'm pretty sure is irrelevant to the difference of square. Let's find out if we have something similar. If not, we're going to move on to the next set. Okay, so we can move on to the next set. And let's say if we can find some question that's pretty interesting. Let's start studying again. Okay, so all right, so again, this is nothing to do with the difference of square. Let's see if we can find out differences. By the way, guys, if you have questions with these guys, feel free to let me know. I can show you guys a video walkthrough for these ones too. Again, there is a specific way that you can use, and very, very simple. You just have to do the cross multiplication method, just like what it shows you over here. I can record another video for you as well. Okay, let's see if we have something that deals with x difference of square. So it seems like everything here is pretty much that. Okay, let's move on. Okay, so next set. Let's see if we have something here. This seems interesting. You know what? We're going to talk about this for now, okay? So let's take a look at example. We have, although this is not difference of square, just to give you guys an idea, but we have two terms. What I see is 3x plus y to the power of 2 plus 4 times x plus y. If we were to find out what they have in common, at least they have x plus y in common. Why? Because this 3x plus y to the power of 2 is really just 3x plus y and x plus y again, plus 4x plus y, right? They have x plus y in common. All you need to do, take out the x plus y. That's what they have in common, both of them. One term, two terms, right? They have x plus y in common. So I take that out. What I have left from the first one is I have 3x plus y. Still there, right? And then for the second term, I have 4 left. So if I open it up here, I get 3x plus 3y plus 4. And then over here, we got x plus y. Okay? Pretty straightforward, right? So with that, let's try something more challenging, something else. Is this difference of square? Nope, this is not difference of square. And this is not difference of square either. Okay, but this one is a little bit more sophisticated. Let's talk about this equation as well then. Okay, so x minus 3y, x minus 3y. I can see right away. And also I have the 2 in common, I have the 2 in common. So to me, one of the way I can do it is I like to break things down. When I break things down, it means I like to rewrite things. X minus 3y, x minus 3y, right? So this is the same as 2 times x minus 3y to the power of 2 plus 4x x minus 3y. They have x minus 3y in common. Take that number out. x minus 3y, at least I have in common. Then I see the 2 and 4 over here, they have 2 in common. So from the first term, which is this term here, if I take away 2 times x minus 3y from it, when I say take away, really what it is it's dividing it by it, right? Because it's glued together using multiplication. Then for this term, I have x minus 3y left. And then for the next term, I have 2x left. Why do I have only 2x left? Because if you use 4x, x minus 3y divided by 2 times x minus 3y, I only have 2x left. So this one will be 2x minus 3y, x minus 3y plus 2x. And you would see that x plus 2x is 3x minus 3y. Ooh, you can do a mini factorization even inside a bracket as well. Because I have the 3 in common, so I take the 3 out, it becomes 2x minus 3y, 3x minus y, and then that 2 and 3 will multiply together, x minus 3y, x minus y. All right, let's move on. All right, so this like, oh, nice. So this one is a combination of factorization and a little bit harder settings. Okay, I like this. Let's talk about this question and then we can do a couple examples here as well. So first of all, I look at this, I look at these two terms. I'm like, let me put my detective hat. What do they have in common first? So first of all, at least I have a in common, right? And also have x minus 2y in common. Do I have to separate it out? Based on the previous one, I think you should be good. So I'm going to write down a x minus 2y, right? That's what they have in common. So then now I need to figure out, I create a bigger bracket over here. What I have to put in is what I have left from the previous calculation. So a to the power of 3 times x minus 2y, what I have left here, if I divide it by a times x minus 2y, is I will have a squared left, okay? And then from a x squared times x minus 2y, if I divide it by a x minus 2y again, I will have x squared left. So did you see this is your difference of square again? 100%. So nothing changes with the first one. A minus x, a minus x, a plus x, a minus x. So this is your answer. So compare this with the original this. They are the same. The only difference is that this is you wearing a t-shirt and this is you wearing a jacket. Nothing changes. It's just the form of it changes. Because the previous t-shirt guy, what he does is that it's not really connecting everything by multiplication. It's not glued together. It's a little bit away. But in a new format that you did, you're gluing everything together. See, everything you have, a times that, everything is multiplied together, right? So that's why that's the magic of factorization. It's just changing the shape of the original question. So let's see this one. Well, this one is pretty much the same. We could try, well, this is the same as well. Okay, so this is nothing too hard. You're factorizing it out inside a bracket, right? You're factoring out that, so shouldn't be a problem here. Because again, the knowledge you see on this page is based on the knowledge that you learned from previous pages. It's just that the steps gets a little bit further, a little bit more complicated. But at the end of the day, you'll be able to solve any factorization if you know the basic concept. You just have to know how to rearrange things and be creative about your calculation as well. So we'll move on until the part where I feel like, hey, we have to tackle it. Ooh, this is going to be our topic today. Okay, now look at example here. We have this part subtracting another part here. Let me ask you this. Is x plus y to the power of 2, basically x plus y times x plus y, right? Minus z to the power of 2. So does this actually match what we learned before in terms of difference of square? Let's see the difference of square one more time. Difference, do I have the difference here? I do, right? It's basically two terms subtracting each other. Of square. Where are the squares? I see a square here. I see a square here. So my idea, my understanding is that, okay, no matter what I have all that, W, Y, oh no, probably not Y, W, Z, oh, I don't know, Z, J, M, right? I've squared all of them together, minus P plus Q minus H plus C to the power of 2. This also fits in the idea of difference of square, because difference, yes, they're difference. Square, yes, I have square. So all you need to do, remember, this number, in this case, everything group up, minus that number, everything group up, all right? This number plus that number. And then what? This number minus that number. The idea is the same. This number, that number, this number, that number, right? Same formula. So with that being said, let's try one of them. Let's try question number 5. Oh, I mean low power. It's okay. We have time. I have two terms subtracting each other. Oh, I see the subtracting. First of all, I will find out that do they have something in common? In this case, I can't really take out everything cheaply. So what do I think? Oh, this one is x minus 4y to the power of 2. So this is this number. The whole thing here, right? Don't worry about just the x or just the y. Minus that number. That number, which one's that number? 4z to the power of 2. Let me think. Can I actually rewrite this as that? Ah, yes, I can, because 4z squared is basically 2z to the power of 2. So this is that number. So this number, x minus 4y, plus that number, 2z, and then this number, x minus 4y, minus that number. And that's it. Really, that's it. I had two terms multiplied together. No problem. Using the formula, right? Okay, now let's move on to something a little bit more sophisticated, a little bit harder. So let's, for example, this one. We're going to do a question together. Ooh, I'm going to love this. Okay, let's do this one first. Number 8. When we're doing number 8, again, difference of square. Difference, I got difference. Do I have square? Oh, I have a square here. I also have a square here. So remember, this plus that. This minus that is the format or formula we're trying to get. Right? I'm just trying to simplify this. What's this number? This number is number what? I would just, I don't mind, I don't care. I just want to put it here. That's this number, right? Plus that number. What's plus that number? Plus that number, it seems like underneath the square is y minus x. I don't mind. I just group up together. I'll sort it out later, okay? Then this number, what's this number? X minus 3y. Minus that number. In this case, be very careful because remember, that number is y minus x. So I would just have a little bracket because I know that signs needs to be changed. Although mathematically, I really should put a bigger bracket here, but you know what? You get what I mean, right? So I'll just put it that way. Now, let me sort things out inside here first. X minus x, nothing. Negative 3y plus y is negative 2y, all right? So again, do not worry about, oh, how come now I only get negative 2y? You already done your part. you had this number plus that not number times this number minus that number. You already did your part. It's just that you have to do some housekeeping afterwards to simplify stuff, to make things a little bit nicer, easier. Okay? So that's still within the bracket, right? And then this number, subtract that number, I got x minus 3y minus y plus x. So I got 2x here, right? You can simplify and do your calculation right here, right? Minus 4y. Oh, in this case, I can also take out the 2. So we'll stop there a little bit. Why? Because up until now, you might be feeling like, oh, this is actually completely out of my league. I couldn't figure out what's going on. So again, I follow my rule of difference of square. I find the difference of two square, square and square. I don't care about what's underneath the square. This number is x minus 3y. That number is y minus x. So x plus 3y is this number, and y minus x is that number. I just follow the formula, just like a robot. Well, probably not like a robot, but you get what I mean. First, I add them together for my first, then I subtract them together, all right? You see what I'm going for? It's just that for the subtraction, as long as I see the negative or subtracting, I always have a bracket because I know that the signs need to be changed. So over here, I get x minus x canceled out, plus 3y plus y. Oh, I made a boo-boo here. See? This should be minus 3y. Almost screwed that up. Okay, x minus 3y here. Okay, so this will give me negative 2y. And don't worry too much about it because that just comes from my calculation inside the bracket. We're not solving this still. We're just representing it. We're simplifying it. Inside this, I got 2x coming from the x minus negative x becomes plus, so it's 2x minus 3y minus y become negative 4y. So this, I will take out the 2, becomes 2x minus 2y. That's why here, I can still take out the 2 out of the 2x minus 4y, which I will get negative 2y times 2x minus 2y. So that 2 will multiply with the 2 before that, negative 4y x minus 2y. My final factorization looks like this. So it's a little bit weird in terms of looking, but remember, look doesn't matter. What matters is the actual formula, the actual equation of it. So the negative 4y times x minus 2y is, again, exactly the same as this guy here. But, you know, in this case, it's actually wearing a heavy jacket, right? And then it's just changed it to tank tops, maybe. But they're exactly the same. Okay, so the last question we're trying to do is that we're going to do, you know what, we're going to do something that looks like this. Okay, we're going to do this. This question, number 7. First, when we're dealing with the 9x squared minus 9y squared minus 6y minus 1, how do we find out what do they have in common? Like, do I have a lot of things I can refer to so that I can break this down into different pieces? Huh. Let's try different things. Again, we can be creative. We can try different things. We can fail and fail again and try different things again, right? And but the key idea is that before you're doing this type of question, always refer to what the example is trying to tell you. So example is trying to tell you that, okay, I can take advantage of the first three numbers and the next part, then I create a different square. So maybe I can try something like that again. I don't know yet. Let's try it. For 9x squared minus 9y squared minus 9y, I can minus 6y. I can at least take out what? 3 out of it. When I take out 3, I have 3x squared minus 3y squared minus 2y, and then minus 1. So in this case over here, do I want to take the 3 out of this whole thing and minus 1? Because this thing does not give me a full complete square though. So my thought have to be shifting a little bit, right? It's okay that we factorize first, and it just doesn't make sense for me. I couldn't move forward because this 3 is really blocking my thoughts because I can't use difference in square in this question. So how do I do this? Let me try 9x squared minus 9y squared plus 6y plus 1. Did you see what I did? What I did is that I separated different parts. Before I was grouping up the first part, taking out the 3. But right now, I'm putting this together. Why? I have a sense of this being a complete square. Because when I factorize it, you can try it out yourself, this actually gives you 3y plus 1 to the power of 2. And then the first 9x squared and minus that, ooh, I remember my DOS, difference of square. So 9x squared is basically 3x to the power of 2 minus 3y plus 1 to the power of 2. So I got my difference of square, right? I got my this number and I got my that number. All I need to do right now, this number, which is 3x, plus that number, which is 3y plus 1, and this number, 3x, minus that number. In this case, always put a bracket, right? Now, 3x plus 3y plus 1, and then 3x minus 3y minus 1. That's my final answer. That's it. There's nothing I can do to simplify or take out more things, and this is it. So hopefully, in this video, you get the full idea of how to rearrange the terms to make sure that it fits the DOS, the difference of square. As long as you can find that, you have the detective eye, you will be good to go. Okay, so hopefully this video help you. If you have any further questions, please let me know, and I can have another walkthrough for you. Okay, thank you.